In this episode, we're going to show why we are wrong to think that we're mastering our understanding of the universe, why we are simply well-dressed monkeys playing around with primitive tools and thinking that we're smart. But we will be, and we're getting there faster than any other time in human history. In this show, I mentioned the quote often attributed to the Victorian giant of science, Lord Kelvin. There is nothing new to be discovered in physics now. All that remains is more and more precise measurement. I also mentioned that in less than 20 years, possibly the two greatest and most influential discoveries in physics were made: the general theory of relativity and quantum theory. The former explains how gravity works, predicts black holes and gravitational waves. The latter underpins every electronic device you hold and upon which every future discovery will depend. And this made us realise that in the first half of the 20th century we'd broken through to a deeper understanding of the universe we live in. Newton's laws of universal gravitation had stood for 230 years. In fact, they still work today and are good enough to calculate ballistic trajectories or chart a course for deep space missions. But Einstein showed us how gravity works by warping space-time, meaning that all objects are travelling on a curved surface being pulled into a gravity well, unless they're travelling fast enough to escape the pull. Realising that there's a world that exists beneath the atomic world, that is, a quantum world, that obeys different laws to the large-scale objects we see and interact with every day, allowed us to understand lots of real-world mysteries, like how our sense of smell and photosynthesis in plants work, and the biggest impact on our world, it allowed us to invent the modern technological age. So this is great, right? We're really smart now. We've figured this stuff out, understood a load of stuff we didn't even know we didn't understand, and invented the modern world. Well, no, I don't think so. Someone undoubtedly said this in a more humorous and pithy way than me, but the more we understand, the more we realise we don't understand. For some people, that's unnerving. For you and me, it's exciting. Gravity is a great example. We've always known how to walk, run, jump, and throw things ever since we were primitive ancestors of humans. We navigated a world that obeyed certain laws, even though we didn't know they were laws until Newton. And Newton's work allowed us to calculate gravity, or more precisely navigate it. But we were very aware that we still didn't know how gravity worked until Einstein. But even now, we still don't know what gravity is. It might be caused by a particle that we haven't observed yet. It might be a force from another universe that's, luckily for us, bleeding into our universe. We just don't know. And we probably should know, right? It seems quite important. And this is why I say that we aren't smart. Don't get me wrong, if we exist as a species long enough, we're going to be really smart. But right now, nah. I'm going to do a show at some point on how lazy our ancestors were. I don't mean your parents or grandparents, especially if they worked down a mine or defended us against fascism. They worked really hard and allowed me to be so flippant in this video. But think of it this way. Humans have been humans for around 200,000 years. Before that, we were primate-like mammals, then primitive hominids, then smaller-brained ancestors like Homo erectus and Neanderthals. But for 200,000 years, we've been as smart as we are now. And while we used that time to develop architecture, the wheel, compasses and writing implements, it wasn't until around the time that Newton was writing down his laws of gravitation that he and his luminaries were developing a framework for understanding the world around us that would transform it exponentially. That's not to say that the Greeks, the Incas or the Egyptians didn't increase their understanding of mathematics and astronomy, anatomy or warfare, especially warfare. Every civilization saw the need for military tech. But out of that 200,000 years, the curve was painfully slow for the first 200,000 years of it. But then came Gutenberg and Pascal. Then came Newton and Lavoisier. Then came Newcomen and Fahrenheit and Faraday, and the rate couldn't be stopped or slowed. But that doesn't mean we are now smart. We are no smarter than we were 200,000 years ago, when we were just starting to develop spoken languages, but we're standing on the shoulders of our ancestors, and each generation knows more, thanks to previous ones. And so we come to the point where just a few years ago, astronomers discovered a planet so far away that if you shone an ultra-powerful laser at it, it would take 320 years for the beam to reach it, travelling at the speed of light. The planet's star is already running out of fuel and puffing up in its death throes, meaning that this newly discovered planet will be absorbed by its star in the next 100 million years, which is a blink of an eye in cosmic terms. In fact, because the planet is 30% larger than Jupiter, but only has a fifth of its density, it has the same density as polystyrene or styrofoam. The ability to find and know this wasn't possible even 10 years ago. And as soon as Europe's Cheop spacecraft was launched and was ready for work, it took a look at this planet, as well as a super-Earth-sized lava world 40 light-years away, and a warm Neptune-like world evaporating in the glare from its host star to characterise their properties from so far away. Well, the ability to do this wasn't possible just 3 years ago. And it's easy to think, like a certain Victorian giant of science that I keep banging on about, that humanity is at the peak of its powers and has already discovered all the important stuff, leaving nothing but the crumbs to vacuum up. But 10 years ago, we hadn't discovered the Higgs boson, a critical constituent of particle physics that gives objects mass and picks away at how gravity works. 10 years ago, we hadn't discovered gravitational waves, a new way by which massive astronomical explosions can be seen and better understood. 10 years ago, we didn't have the latest upgrades to gigantic particle colliders probing the extremes of our knowledge of physics. We didn't have the James Webb Space Telescope, able to see further into the universe than any other telescope. But there are still fundamental riddles to be solved. In the 1930s, we realised that what we thought was the entirety of the universe isn't everything. In fact, astronomers have since discovered that what we can see is only 5% of the stuff that's out there. The rest is made of exotic matter and energy that we know very little about, so we call them dark matter and dark energy. So what's 95% of the universe made of? As we discussed in this show, we've found over 5,000 planets in our galaxy and can extrapolate from that on average every star has at least one planet, and there could be as many as 300 million habitable planets in our galaxy. So does life exist elsewhere? And of course, to bring things full circle, what's gravity? We have no more idea than Newton, our cave-dwelling early human ancestors, or our insect-eating mammal ancestors. Despite our arrogance at how far we've come to build smartphones, the internet, particle colliders and space probes, we're only at the foothills of discovery, with only the first generation of instruments to chip away at these questions. When we better understand how to engineer the quantum world, we'll be able to see through objects, predict future events, build computers billions of times more powerful than the fastest supercomputers today. What will those instruments and exponentially advancing artificial intelligence allow us to build to probe our world? How long until we can live forever, manipulate gravity, visit worlds anywhere in the universe, build our own universes? In 10, 20, 30 years we'll have better equipment, more understanding and ever more exciting questions that understanding will throw up. If we survive long enough as a species, imagine what instruments we'll have in 1,000 or 1,000,000 years, what we'll know then and the questions they have that we can't even conjure up, primates that we are.